Okay, so this super short unit, I used to do it as a mini unit, but now we do it kind of as a full unit, although it's super short. But we talk about polyhedrons, which is three-dimensional shapes. So a polyhedron is a three-dimensional figure whose surfaces are polygons. Now, what's a polygon? It's a shape like a hexagon, octagon, pentagon, quadrilateral, triangle, all of those are polygons. So they're all the ones that are two-dimensional shapes that are made up of lines that connect together. So in a polyhedron, each polygon is called a face. The edge is the segment that is formed by the two faces, and the vertex is a point where all three of the edges meet. And we have a formula that works with any polyhedrons that we have. It's called Euler's formula. I know it looks like Euler, but it's pronounced Euler. So Euler's formula says the faces plus the vertices equals the edges plus 2. So F plus V equals E plus 2. And that works with any kind of shape that we have. So if, let's say that we were going to draw a prism. And then I connect those. There's our prism. That's how I draw one. Just draw two boxes and then connect the points. And we can look at this one. This is a three-dimensional shape. So each of these kind of square or quadrilateral shapes that I make, that is called a face, the whole thing together. There we have a face. The edge would be the part that connects the two, so all the lines that I put in. And then the vertices are all the corner points. So that's the difference between a face, an edge, and a vertice. So the vertices are the corners. The edges are the lines, and then the faces are kind of like that whole quadrilateral shape in the front. Yeah. So the yellow is this part right here, this whole face. We could shade it in. That's a face. And then the edge is each line, and the vertex is the corner where they meet. So if you think about a box, usually I look at like a Kleenex box or whatever, then you have those 4 kind of points or 6 points that you have on your box. It's always good to kind of look at something and put your hands on something that's the same kind of shape. So a Kleenex box usually works well to talk about what they are, what the different parts are as well. Now, there are some special polyhedrons. These are our regular polyhedrons. So go ahead and write down these names of our 5 regular polyhedrons. Regular means that they all have the same angles and the same side lengths. So all the side lengths are the same, all the angles are the same. You will see these on tonight's homework that you have. You'll see them in a couple of different ways, but these are our 5 regular polyhedrons. So the first is a tetrahedron, and you don't have to draw these pictures. I know these pictures are really hard to draw. If you're trying to draw them, good for you. I can't. You can look them up online and see what they look like. But a tetrahedron has 4 faces. What are the shape of those 4 faces? Triangles, and they're more specifically what kind of triangles for it to be regular. Equilateral, that's it. Equilateral has all 3 sides the same and all 3 angles the same. A hexahedron is this shape right here. A lot of us would probably call it a what? A cube. It's made up of squares, that's right. Then we have an octahedron, octa 8. So it has 8 sides, but all 8 sides are triangles. They're all equilateral triangles. Good. And we have a dodecahedron, which all the faces are pentagons. And these are what we call regular pentagons. So the side lengths are all the same and the angles are all the same. Also kind of looks like a soccer ball. A lot of people call this one the soccer ball. And it has 12 pentagonal faces. And then we have an icosahedron. It has 20 faces, and all faces are equilateral triangles. If anybody has seen those Moravian stars, especially around Christmas time, this is the inside of a Moravian star. It is an icosahedron with the 20 sides, and then what they do is they make longer triangles to kind of put as the points of the star that comes off. But this is the base, this is the inside. We used to do a project when we taught just straight geometry where students had an option to make one of these icosahedrons and attach the stars to it. So I know that was one that I actually did when I was in 6th grade. I didn't, it was really bad though. I painted it like, well, I didn't paint it. I colored it like hot pink. So, you know, because you're 12. So, but icosahedron is that last one. So these 5, you need to make sure you know what they are, but not necessarily, you won't have to draw them or anything like that. But our 2 bigger ones are the hexahedron, the cube, and the icosahedron. You hear those probably more than you hear the other ones. But they have the same equal faces on either side. All right, let's actually do some math now. Let's practice using Euler's formula to find the missing information. So write down these 3 problems. You might want to write down use Euler's formula at the top so that way you know what you're doing. And then we will solve for those blanks. So we're going to use Euler's formula, which says the faces plus the vertices equals the edges plus 2. Right? Okay, so we don't know the faces. We know there's 9 vertices. We know there's 15 edges. And then we just add 2 at the end. So Euler was a really smart man who had nothing to do and found out that this worked on all polyhedrons. We say, thanks, Euler, and we use the formula. All right, so 15 plus 2 is 17. and then we would subtract the 9, so F is 8. So this shape would have 8 faces, 15 edges, and 9 vertices. You don't have to draw it, you're just filling in the blank. So let's solve our next one. Our next one, we're missing the edges, but we still set up the same equation. The faces plus the vertices equals the edges plus 2. So 8 plus 12 equals E plus 2. 8 plus 12 is 20, which equals E plus 2, so E is 18. So just plug it into the formula. Faces plus vertices equals edges plus 2. So just plug it in and solving for the one that you need. Now when you get to problem 3 though, it gives you a description. So if it gives you a description, what might be best is to visualize what it is. You don't have to set up a formula if you don't want to, but visualize how would we have a polyhedron with 8 triangular faces. It is an octahedron. It's actually this shape right here, right? 8 triangular faces that go together. If you have a hard time visualizing this for the homework, type it in Google. Type in polyhedron with 8 triangular faces, and it will pop up with an octahedron. Okay? Now, what did we need to find on this octahedron? Well, we wanted to find the number of edges. So edges are the lines. So if I go back in here, I want to count how many lines that we have. Now we can't see them all, so we kind of got to picture what we have and how we have it. Let me see if I can find a bright color to help us out. So we are putting together 8 triangles. So what is that going to look like? Well, we're going to have 4 on top and 4 on the bottom, right? So if I put together 4 triangles on top, there's 1. But that side connects to this one to make 2. That side connects to that one to make 3. And then we have our 4th. So how many lines do we have on top? 4. 4 edges on top, right? It would be the same for the bottom, right? If we took 4 triangles and put them together. 1, 2, 3, 4. But then where they connect together, we also have lines. How many lines do we have here in the middle? 4. So we have 4, 4, and 4, which make 12. Now, we could also set this up as the equation. Faces plus vertices equals edges plus 2. Well, edges is what we want to find. We know that it has 8 faces because it told us. So how many vertices will it have? So vertices are the corners, the dots where they come together. So they all come together up here at the top. That's 1. At the bottom, that's 2. And in the middle, they have 1, 2, 3, 4. So 4, 5, 6. So 8 plus 6 is 14. And then when we solve for E, we get 12. So whichever way you want to think about it, you can use the formula. You can just go through and count. But if it gives you that description, you need to visualize, hey, what would that look like? And then you can do it. For your next several problems, I have them printed out for you because I didn't want you to have to draw these things. You're welcome. Now, there may not be, if you like lined paper though, for the problems that we do on the back of this, you might want to use your lined paper instead. Okay, so next on our list is a cross section. We might do more with cross section next week, but we just don't have the time today. We might do it tomorrow. I don't know. All right. A cross section, though, is the intersection of a solid and a plane. You can think of a cross section as a very thin slice of the solid that you have. You could also think about the cross section as a stamp. Okay, so right here, this first picture is kind of like my Kleenex box, right? If I took a chainsaw or something and went, and I cut it in half, and then I turned that towards you, what 2-dimensional shape does it make? Square. Or some people might say a rectangle. Square or rectangle would work. It makes a quadrilateral, right? That's your answer to the question. You say, what two-dimensional shape does it make if you cut it and then pointed it towards you? What does it look like? So in this case, y'all were saying it's a square. You could also think about making a stamp of it. If you cut it and then you stamped it on a piece of paper, that stamp will look like a square. Now, this one, instead of being squares on the end, now it's triangles. Now, it is kind of hard to see how it cuts, but I think it's kind of parallel to that base. So what would this one make? It does look like a house, but we want two-dimensional shape, so the two-dimensional shape would be the triangle. So if it cuts parallel to the base, it's going to look like the same base. So I know that picture is kind of hard to see. It's kind of hard to draw three-dimensional objects on a two-dimensional board. So remember, when you name a cross-section, it is the two-dimensional shape. So you might want to write this down. It's the 2D shape that it makes. Some people like to draw the pictures, but I like for you to tell me the actual shape that it is. And sometimes they can be a little complicated. Like, for example, what if I took and I cut out a circle in the middle of this? So you would say it's a triangle with a circle cut out in the middle. So sometimes you need a little bit more description. All right, let's look at these examples. So it says draw a figure that has the same cross section. We're not doing that. We're actually doing this one. I don't know why that's there. Which of the following is the cross section by slicing the cylinder as shown? So now we have a cylinder, which is kind of represented by these cleaning wipes that we have. If I took this and I cut it diagonally, but then I stamped it on a piece of paper, what would it look like? Would it look exactly like a circle if I cut it diagonally? And then you would stamp it. C is the correct answer here. Yes. So D is what it would look like if I was holding it in my hand and showed it to you. It would look like D. If I cut it parallel to the base, where it was just a horizontal cut, it would look like A. But if I cut it diagonally, and then I go through and stamp that, it's going to match with C instead. Does that make sense now? Okay. Now, this next example, it says the shape at the right was created by rotating a two-dimensional shape about an axis. So what do you do when you rotate something? You turn it. You spin and turn and spin and turn, right? So if I spin and turn, which one of these would make that shape? C would be correct. A would only make the top portion, but it needs to have 2 points for the top and bottom, so it's got to match with C. All right, so next we're going to talk about some prisms and cylinders. So I got to open up a new file for that because I'm putting these together. So go back to your notebook paper and write down these formulas because I did not include them on your paper. There we go. Now we're going to talk about cones and pyramids tomorrow, so today is just cylinders and prisms. So today's just prisms, and then we're talking about cylinders in a minute. So we're going to start with just prisms first. I guess we could put just prisms on here. If you already write cylinder, it's fine. each shape that we talk about today and tomorrow is going to have 3 formulas each with them: a lateral area, a surface area, and a volume. So a lateral area is the sum of the areas of the faces, but not the bases. It'd probably be a good idea to draw the pictures the best you can for this, yeah. So lateral area is kind of like you're painting this room. If I told you that we were painting this room, what would we paint? The walls. I wouldn't paint the ceiling or the floor, right? I just paint the walls. That's what lateral area is. No. Not every shape. So lateral area is just the part that's around these walls. Now, surface area is all surfaces. So that's where we would paint the 4 walls, the ceiling, and the floor. We're going to paint everything. Or if we had a box, we're painting the whole outside of the box, top, bottom, all the sides. Volume is where we would fill up this room with paint and I guess swim in it. So that's the difference between lateral area, we're painting the walls. Surface area, we're painting the ceiling and the floor along with the walls. And volume is we're filling up this room with paint. So that's what our 3 formulas represent in our shapes that we're going to talk about. So our first shape, we have a prism. Now, a prism is a polyhedron with 2 congruent faces, and we call those the bases. So if we are looking at this shape here, our rectangular prism, the bases are going to be the top and the bottom. They're the parts that it kind of sits on. So this is a base, but then the congruent base is the one at the top. So that would be our 2 bases. When we look at a triangular prism, what would be the 2 bases? The triangles. They don't always have to sit on the base, especially when we have triangles. So what do you notice about these bases? The 2 triangles and the top and the bottom, those 2 faces are not only congruent, but they're also parallel from each other. The 2 bases will always be parallel to each other. So if you have a rectangular prism, just look at what it's sitting on. That's the base. If you have a triangular prism, the base is the triangle. The base is always the triangle in a rectangular prism. Yes, triangular prism. Goodness gracious. Okay. I'll get it right eventually. All right. So here's the 3 formulas that you need to know. For lateral area, we take the perimeter of the base and we times it by the height. That will give us how much we need to paint these walls if we're painting this room. For surface area, it's pH again. So notice these 2 repeat, right? Plus twice B, where B is the area of the base. Because how many bases do we have? 2. So that's why we have 2B. So now we're doing our lateral area plus the top and the bottom. To find volume, it's BH, which is area of the base times the height. So let's do some examples. You have some on your paper there that are kind of drawn for you. So if you want to use your sheet, or you can also put these down on your notebook paper. So here we have this shape. Now, how I always like to start out is I like to kind of trace that base a little bit more. So what is my base? The bottom part, what numbers does it have on it? 5 and 8. This is my base. So 5 and 8 has the base on it. What is 3 out here? That's the height. That's h. I like to label that to begin with because that's going to help me with all my formulas that I have. All right, so let's go through and find first our lateral area, which is pH. Well, P stands for what? Perimeter of the base. And how do you find perimeter of any shape? Add all the sides up. So I have a 5 plus 8. Then over here I could put another 5 and another 8 because it's a rectangle, right? Opposite sides are equal. So what's 5 plus 5 plus 8 plus 8? What is it? 26. I thought you just said 6 for a second. I was like, what? So this would equal 26 times my height, which we already said was 3. So grab your calculators and let's multiply those out. 26 times 3. Oh, my calculator's died. Is 78. Don't forget to put units on this. What would the units be? Inches squared, because it's talking about area. And that's it. That's all that we need to do for lateral area. Let's do surface area. Surface area is pH plus 2b. Now don't forget, we already found pH, didn't we? pH was our lateral area, which was 78. So let's just reuse that number. 78 plus 2 times b. Now what does that b stand for? Area of the base. So what shape is this? It's not a square, but a rectangle. How do you find area of a rectangle? Length times width, length times height, base times whatever. You can say either one of those. So we're multiplying what two numbers? 5 and 8. So what's 5 times 8? 40. So 40 would go in for B. I'm going to slide this over so I got room to write. So we have 78 plus 2 times 40. What's 2 times 40? 80. So what's 78 plus 80? 158. And then units would be inches squared. All right, now last we're going to do our volume. Volume is B times H. Well, we already found B to be 40, and we know our height is 3. So what's 40 times 3? And now this is volume. Volume is not inches squared, but now it's inches cubed. That's right. Volume is cubed. You might have heard about volume as a box as being length times width times height, right? Yeah, this works the same way because our length is 8, our width is 5, our height is 3. We just already did 5 times 8 up here to get 40. If you want to use that formula, you can, but this formula works for any prism that you have, no matter what shape the base is. All right, let's do another example. Example 2. Is this what y'all have on y'all's paper? There's a lot of examples on the back. Oh, okay. I didn't do any more rectangular prisms, but I wanted to do some triangular prisms to help us out. Okay, so if it's a triangular prism, the base is a triangle. So let's highlight that triangle. We're going to look at this right here. Specifically, what kind of triangle is that? A right triangle. It's also scalene, but also a right triangle. So the measurements on our right triangle are 8 and 15. So what is this extra 8 over here? That's the height. So go ahead and mark that as H. Now, if you think about your 3 formulas, we have pH, pH plus 2b, and BH. We already know what H is for all of those, but we need to figure out what P and B are. P stands for what? The perimeter of the base. We have 2 sides, but we need the third side. We need 3 sides. What are we going to have to do? That's correct. We're going to have to do a little Pythagorean theorem on this. So draw that triangle over here to the side. It is a right triangle. We have 15 here, 8 here. We don't know this part, so I'll call it X. And go ahead and do your Pythagorean theorem. It's nice when it's a nice pretty whole number, isn't it? Yes, it is. So yeah, square root of 289 is nice and even. It is 17. So you could go ahead and put that back in your picture if you wanted to. So now we need the perimeter of that base. So we would just add the 3 sides. So what's 8 plus 15 plus 17? 40. So if you want to, you can write that to the side because we're going to use it later. That P is 40. And then we can plug it in our formula. So it'd be 40 times the height of this prism, which is 8. What's 40 times 8? 320, and then it would be meters squared. All right, and let's do our surface area. Remember, you can repeat with surface area because we already know pH from above. pH was 320. So it's 320 plus 2 times B. Now we have to find B. B stands for what? What about the base? The area of the base, right? So capital B is the area of the base. Well, this base is a triangle. What's the formula for area of a triangle? 1/2 base times height. Now, in our case, look over at this triangle here that you drew, okay? Look at it as a right triangle. What's the base of that right triangle? 8. And what's the height? 15. Those are the numbers that we want to use. We want to use the 2 legs as the base and the height to find B. So what is 1/2 times 8 times 15? So 60 would go in that spot. So you have to remember some other things back from way back when, the area of a triangle, area of a rectangle, to figure this out. All right, so here we have 320 plus 120 or 40, and don't forget units, meters squared. All right, so last we have volume, and we already found these 2 things. The area of the base was 60, and the height is 8. 480 meters cubed. Sometimes I think the hardest part is finding the area of the base. Everything else is just plug in, plug in, plug in. All right, let's do one more. What kind of shape is this last one? Triangular prism. So what's my base? The triangle. So this is my base. So what's my height? 50. The height of the prism is the distance from base to base. So this prism height is 50. It's just laying on its side. So remember, the base has to be the congruent parallel shape. So if I chose this rectangle that it's kind of sitting on, does it have another congruent parallel shape? No. So you have to use the triangle. So if it's a triangular prism, use the triangles. Now, good news about this triangle is its 2 legs are 8 and 15, which is just like this triangle, except reversed, right, with the legs. What does that mean the hypotenuse is, though? 17. It's going to be the same. So what's the perimeter of that shape? 40. And what is the area of that shape? Still 60. If we reverse the two legs, it doesn't matter. Every other measurement's going to be the same. So we actually have all the information we need, right? Okay, so let's find our stuff. Lateral area is pH. So it'd be 40 times 50. A lot of people want to use the height of that triangle, but it's not. The height of a prism is a distance from triangle to triangle. So what's 40 times 50? 2,000. And then it would be feet squared. Surface area, pH plus 2B. Well, what's P? H. 2,000 plus 2 times B, which was 60. So it's 2,000 plus 120, which would give us, good, and feet squared. Volume is BH, so we have 60 times 50, which makes 3,000 feet cubed. Very good. Now, on your homework, write down the formulas with every single problem, because the more you write it, the more you remember it. And on Tuesday, we have a formula quiz, and so you need to know these three and Euler's formula. Okay. We got one more thing to talk about today, which is cylinders. What's the difference between a cylinder and a prism? Cylinders have circles, right? This is a cylinder, which actually is a prism with a circular base. So if we have circles, remember our little song? Take your finger, the jar circumference equals 2 pi r. Now let's stop right there real quick. Circumference is the same thing as what? Perimeter. Circumference is the same thing as perimeter. So instead of all these p's, guess what we're going to put? 2 pi r, or like c's. Now, B was area of our base, but our bases are now circles. For area, you multiply r squared times that number pi. So instead of capital B, we're going to put pi r squared. And guess what? Now we've created the formulas for cylinder. Dun, dun, dun. Yeah, like so exciting. All right, write down those three formulas for cylinder. You may want to draw the picture as well. But honestly, if you know the formulas for prism and you know the little song, circumference and area of a circle, you just replace. That's all it is. It's just replacing P with circumference, 2 pi r, and replacing B with area, pi r squared. You may see me carrying around this index card in this unit. This is my cheat sheet for this unit, because each year I try to make sure that I memorize them, and I do for that unit, and then they kind of just flutter away from my brain. So I always have to pull them back out. So lateral area is 2 pi r h. So r is the radius of the circle of the base. And h, again, is the height from base to base, so height from circle to circle. Okay, so remember, height of prisms and cylinders are height from base to base, which will be your circles, your triangles, or your rectangles. So that's the only two variables that we need when we talk about cylinders, because we have the information. So you don't have to worry about finding the perimeter of the base or finding the area of the base. You have R and H and you just plug them on in. Now we are going to leave these answers in terms of pi. Okay, so you're not going to use the pi button on your calculator. I promise it's going to be easier, then you'll have to worry about rounding. All right, so let's look at our first example here. Our lateral area is 2 pi RH. Well, what is R in this picture? 3. It actually labeled it for us. Okay, what is H? 6. It's the height from circle to circle. So if we plug in, we have 2 pi 3 6. All you do is multiply the numbers together. What's 2 times 3 times 6? 36, and then tack the pi on. Yeah, you could. So you could just type in 2 times 3 times 6. Just don't type in the pi. So just type in all the numbers being multiplied, not pi. Put the pi with it. Units. You're exactly right. What are the units? Meters squared, because we're talking about area. Now, surface area is 2 pi RH plus 2 pi R squared. Just like the last one, we've already done the first part, right? That is our lateral area. So just replace that. 36 pi plus 2 pi R squared. Not when you're adding. When you're adding, they stay together. Yes. So this second part would be 18 pi. And then we would add those two up. 36 plus 18 is 54 pi. And meters squared. And again, you could type this in the calculator as well. Just ignore the pi. And you could type it in all together if you wanted to. 36 plus 2 times 3 squared. Remember, the squared always goes outside of the parenthesis. So we get 54. So you could type it straight in, how it looks, and still get that same answer. All right, next we have volume. And volume is pi R squared H. So pi 3 squared 6. And really, you could do this in your head too, because what's 3 squared? 9. And 9 times 6 is 54. So this one also equals 54 pi, but it's going to be meters cubed. You'll see that a lot with cylinders, that the surface area and the volume may be the same, and that's okay. They have different units on them, but you may get out the same number. Oh, I did 2 times 3 squared. No, you square first. 3 squared is, and then times 2 is 18. Yep. Yep, so always follow those order of operations. Exponent, then multiply. All right, in our last one, it gives us the diameter, but we need the, what's the radius? And what's the height? 2. That's the only 2 things that we need, radius and height. So it's the height of the cylinder. And let's just type in all of our formulas. Lateral area equals 2 pi RH. So 2 pi 5 2. (20 pi centimeters squared). 2 times 5 is 10, times 2 again is 20. So remember how you multiply. You can only multiply 2 numbers together. Okay. Then surface area is 2 pi RH, bless you, plus 2 pi r squared. Now, just like last time, we can repeat the 2 pi RH is 20 pi, so that can just replace. Plus 2 pi r squared. So 5 squared is 25 times 2 is 50. So 50 pi and 20 pi make 70 pies. Now I'm just getting hungry because I'm thinking about pies. All right. Our volume is pi r squared h. So pi 5 squared times h, 2. And notice this is actually the same formula as this one up here since the height was 2. But 5 squared is times 2 is 50. So we have 50 pi, but now we have centimeters cubed. And it is okay if our volume is less than our surface area. Good. All right, well, we have 35 minutes left of class. I did put on here that this worksheet is not due until Monday in case you guys needed some extra time to get things done. The first 6 problems, you have to find all 3 things. The ones on the back, most of them are multiple choice or trying to find like the cross section or what would it look like. This is not printed in color. If you want to see it in color, check Canvas. I have it in color and printed a little bit bigger on Canvas. So if you're struggling trying to figure out what these things are that are printed in black and white, go there. Okay? But again, this is not due until Monday. Don't forget what else is due on Monday. Kite project, your little mini project of making your kite. Now, tomorrow we are covering pyramids and cones, and we're doing 2 examples of each. So tomorrow's lesson is going to be about a third of what today's lesson was, okay? So tomorrow you should have a lot of time to work in class. You should probably have about an hour, okay? Yes, you can. All right, let me stop this and our handout.